Okay, so this is Killian Cluna, student number 182329906, and this is my rationale behind my resources and assessment. So as you can see here, this is my anticipated difficulties. My topic heading is skew boreholes, and as you can kind of tell, skew boreholes and skew lines is not really a common topic that would be heavily taught throughout the syllabus or and so a student's level of understanding around like the background of this topic wouldn't be great when you're initially teaching it. So like the most you'll be able to get is most students have covered the core principles which relate to like skew boreholes through maths and maybe junior tech graphics or thus far in the course. So things such as rebandments and parallel lines, horizontal lines, and finding true lengths, stuff like this will uphold to the student when they're being introduced to this topic, and linking them to give you a good understanding quick will be ideal. But the main thing I see with this is visualization. When I ask my peers about what they thought with these kind of questions, is the visualization, not even like how it works, but as you'll see now, the layout of the question is just difficult is the words I'd use. If you're not really kind of well versed in this, you look at this and it's very daunting at the start, but this comes with practice and practice. So like as you do more of these questions, you look at this and you pick out key information. So like the altitudes of P and Q are 50 and 35 respectively, things like that, etc., etc. And then it comes to actual visualization of the drawing itself, where to orientation on the page, stuff like that is just difficult at the start for students, but it'll become more natural. So this leads me on to my resource development. So like what abilities are going to address, as I said, visualization. So to combat the visualization issues, I created a 3D model on SolidWorks of the boreholes themselves being drilled down through the stratum. So you have the thickness of the stratum, the head wall, foot wall, etc. And this can be viewed through like manipulating on SolidWorks itself, or you could use things such as the merge cube, which you point your phone at and it allows you to orientate the object in your hand, which is very good for motivation as well. So if a student is struggling, you could give them the merge cube with that linked onto the phone, and they could turn around and orientate themselves to give themselves a better understanding of what they're trying to do with a similar question or the actual question itself complete in their hand. And another thing that also is the drafting. Back to the drafting, students would find it really daunting at the start to start questions. So I created a resource around a sample question of step by step on how to do it. So when you're introducing this topic, as you can see, when to use resources. The first resource can be used anytime from start to finish throughout this topic. So can this, to be honest, but this is very good for the start when you're running through how students should attack this kind of question. Everything from the actual layout of the question, what to pick out, what they need the whole way through to finishing, labeling, etc. So this brings on to my assessment. So my assessment, to be honest, I found this very difficult to do because I try to basically reinvent the wheel, going about it the wrong way, just try to make something up out of thin air. But then as you can see here, I went back to the Leaving Certificate in 2001 and seen this question which caught my eye. It's a nice question. It's pitched very well, pitched at a good level for a college student, for a Leaving Cert higher level student. But I wanted to add something else, so I wanted to use the geometric mean to find the 95 and 75 mean respectively. So the A and B, the altitudes in elevation. I wanted to use this to find it instead of giving the students that to bring it up to more of a college kind of standard. So this is the geometric mean found. So what I done is I drew out the rectangle first. So 47 is half of 95, and then 25 is a third of 75, the two altitudes given. But I wanted to make it even more difficult again and give the students the square and the center point of the semicircle and get them to work back to find the actual rectangle themselves before they get the line to the side, which they'll use later in the question. And then I changed the question a bit also, so part B is different again. So this is the actual sheet they will receive. It's an A3 sheet with plenty of space for the students to work around. The question is up in the top right corner, and the actual geometric mean question is to scale down here to the bottom left. So I left students plenty of room, because often students, especially with questions like this, they start too much in the middle or too much to the right, and when they bring auxiliaries off, they just find it difficult and they start running a page, etc., etc. So I just wanted to allow them more space, more freedom, instead of having all cramped onto an A4 page. So here we see the actual question complete. It's nice, tidy. This to scale, nice and tidy. Plenty of room for writing and rough work. Here's the geometric mean complete, labeled, all labeled. So this is the kind of standard we'll be looking for. And then I have the marking scheme. So we have complete the workings to find the rectangle. So this is our geometric mean. So we have the 47 up here and the 25 down here, which you'll get 7 marks if you get all of this. Then you set up your elevation using your newfound information. So your 75 is altitude A or B, and 95 is altitude A. Bring that all down to plan. That will get you an extra 5 marks. Then to fully answer section A will get you another 9 marks, and then to enter section B will give you the last 9 marks. And then general neatness and accuracy will get you full marks in this question. Thanks very much.